In these sorts of questions, a good shout is to get your own diagram down with key information on. So I've got the first part of the train. Okay, I'm just going to draw them in different colours to identify the forces on each one of them. And then we're told the mass. I'm going to write down the weight. This one, there's going to be a normal reaction force up here. And this one. We're told there's a resistance of 1250. And 9,000. The first one is the engine, and so it's going to have some sort of force pulling it along. Maybe, and it talks about it later on, the driving force. I'll call it capital D. Let's just check. Yeah, the rest is just these approximations for the model. Okay. So in A, we've got some speed. So the train passes through station P with speed 15 and moves along a straight horizontal track with constant acceleration. So that's already bringing in the fact that we can use that. And it was, oh yeah, sorry, U is 15. A is 0.01. And S is 12.95 kilometers. So I have to times through by 1,000. It's going to be 12950 meters. We need to be consistent in our units. Okay, and then we're asked for the time taken to go between P and Q. So for that, I can use S equals ut plus half at squared and create a quadratic. Okay, there's no need to simplify this anymore or even write anything down. Just put it into your class with calculator quadratic formula function. Of course, you just have to rearrange it so it's equal to 0 first. Okay, so t is 700. Okay, so this would actually have factorized, or minus 3,700, which we reject. Okay, good start. Now, the only other thing is that actually we're asked for the time in minutes, and so we've calculated it in seconds. So just need to divide through by 60. .11 recurring. It's not asked for minutes and seconds, so it's simply going to be 11.7 minutes to 3 significant figures. Good start to this question. So now we're looking at the train's motion again between P and Q and trying to find the driving force of the engine and then the tension. Do you know what? I forgot to do that. So there's going to be, actually at the moment, the blue train is just going to be, accelerating to the left. Why is it actually moving along with it? It's because of the tension. And then what's, impedes the engine somewhat, it's having to pull the carriage, and there's going to be a tension going that way. And I've done it in different colors to show which system it's applying to. Now in B, actually, we can when we apply F equals ma, we can decide what part of the system we apply it to. If I apply it to the red part, then I'm going to get an equation with D and T in. So that's a bit of a problem. If I apply it to the blue part, I'm just going to get an equation in terms of T. Um, so one thing I could do is solve to find T and then substitute that in to find D. But there is a quick way actually. Instead of looking at the blue or the red part, we can actually look at the whole system. Apply F equals ma to the whole system, because then the tensions simply cancel out and then I can get D. That is the intention here, because we're being asked for that first. So I'm just going to borrow my diagram. Okay, so F equals ma, this one, on whole system. So D minus 9,000 minus 1250. You can write in plus T minus T, but that's just going to cancel to 0. That is going to equal my total mass, which is 70,000, times the acceleration that we had previously, which was 0.01. So actually I can do that. It's just going to be 700. And I'm going to add on 91250. Sorry, that's not what I meant. So it's going to be 10,250, which gives 10,950 as the driving force. I never actually technically defined it, so I'm just going to write it by it. Okay, so like I said, you could have done the blue, could have found the tension first and then substitute it in, but this is pretty quick and worth knowing actually. It can it can definitely give you shortcuts in some questions. And then finally, we're asked for the tension. So now I'm actually going to do F equals ma on the just on the carriage. We could do it on either one now. Well, not the whole system, but we could do it on the red or the blue. But the blue is a little bit simpler. I don't have to worry about the driving force. And it's also going to be independent. If I did make a mistake on this part, okay, I can actually calculate this part and still get it correct. So T minus 1250 is going to equal 20,000 times that acceleration. That's just going to be 200. Therefore, T is 1450. You could, if you had time, you could then substitute that in. You could do F equals ma on the red system, substitute it in, and check that it works. Let me explain what I mean. We're done with the question. I'm just sort of talking how you could double check now. So we could apply F equals ma on the engine. And then 10950, that's the driving force, minus the 9,000 resistance force, minus the tension. Okay, we could calculate that. and we're expecting it to equal 50,000 times 0.01, which is 500. So just check the left-hand side is 500. Okay, which it is. So that's just a little check at the end to be confident.